Thanks for coming. It's a pleasure to be here in Barcelona. My name is Dražen Perić, and I'm working as an infrastructure platform engineer at kiwi.com. I am also based in Ljubljana office together with my colleague Jan. And for the last couple of months, I have been optimizing serverless workflow in kiwi.com. And for that purpose, we have built a couple of tools that help our developers to build better serverless apps. Today, I'm going to talk about Go in the serverless world. Basically, I prepared a simple Go application and deployed it to three serverless providers, which are AWS Lambda, GCP Cloud Functions, and Cloud Run. You will see that we will move from AWS Lambda towards GCP Cloud Functions, and this is basically what is happening in kiwi.com because we are migrating from AWS to GCP. You will also receive all the examples. The links are in the presentation, so it will be available afterwards. But before we start, I just want to ask who is already using serverless technology? At least a bit. Okay, cool. And probably with AWS Lambda. Okay, cool. All right. So I'll just give you a quick introduction. You probably all heard this buzzword. Basically, you run your code on demand. You pay per usage, and you don't care about infrastructure and scaling. There's already a bunch of services that are offering some kind of serverless approach. But today we're going to focus on AWS Lambda, GCP Cloud Functions, and GCP Cloud Run. When it comes to the question when to use serverless, well, basically there is no simple answer to rule them all, but you can use it, for example, for some fast periodic tasks or some simple APIs and stuff like that. Maybe a good example would be a Slack bot or some cron jobs and stuff like that. So this is our app. Basically, it's called Burja, which means Bora in English. I mean, Burja means Bora in English, but Burja is a Slovenian word. Basically, our app gets the data about the wind. It stores it to the database. And then we have an API that reads this data from the database. So basically, we have a parser that runs every hour. It fetches the data from Open Data SI. It writes it to the database, and then on user request, we basically process this data and return it to the user. So it's really simple, but I wanted to show you how to do it. So if you start with AWS Lambda, so basically, as I said it, AWS Lambda is probably the most popular of all the serverless technologies. It's been there for a couple of years already. It supports a bunch of programming languages, and it works with many types of triggers. We will use DynamoDB database on AWS, and to deploy our application, we will use Serverless Framework, which is basically a framework which can help you to deploy to AWS, GCP, and so on. It helps you write stuff much more clear than it is. So here's a structure of our application adapted for the AWS Lambda. As I mentioned, first we need to install a serverless framework through npm. So basically, this is a package.json file. We also install serverless pseudo parameters, a plugin for the serverless, which helps us to write better serverless .yaml files. Then serverless.yaml file. Wow, you can see a lot here. Serverless.yaml file is basically a config of our whole stack on AWS. So here we define some provider-specific things. We define environmental variables, some IAM policies, resources, and so on. So basically, here in this part, which is not so clear, you can see that we defined two functions. One that is triggering an API binary on a HTTP request, and another one that is triggering the cron binary as a schedule, so basically as a cron job. And on the right side, you can see that we have defined a resource, basically our table where we will store the data. After you deploy this, you basically build the whole stack on AWS, and you get an output, which I will show later. This is a minified example of our cron service. I deleted most of the code, but basically it just parses the data and it stores it to the database. You need to have the main function, because at the end you upload the binary to the AWS, which you will see later is a bit different for the GCP. And yeah, basically there is no more specific things to the AWS here. As I mentioned, we store the data then to the DynamoDB. This is an example for the API. Again, it doesn't even matter that you don't see what's happening here. It just reads the data from the database, it prepares the response and returns it to the user. The only provider-specific thing here is that you need to return some kind of different response and not the usual HTTP response. And as I said, you will receive the examples on the link below, and you can try this stuff on your own, change something, deploy it, whatever. So basically, to deploy this application, you need to add your credentials to .env file and run npm install, run make deploy, and you will have this application running in your AWS account. Which will, after a couple of minutes, you will end up with an example like this. So basically it will output you a JSON file, which I think it returns the maximum and minimum wind speed in Slovenia for the last week. Really useful. All right. Next example is GCP Cloud Functions. It's basically Google's opponent to AWS Lambda. It doesn't support so many languages. You have to do a bunch of workarounds to get things done. But yeah, it works. We are also using Serverless Framework to deploy this application. But as I mentioned there, the plugin for the GCP is kind of dying. No one updated it for almost a year, and it's missing a lot of stuff. So it's okay for this kind of small apps, but I wouldn't recommend it to use it like after your app grows bigger. Instead of DynamoDB, we use Cloud Firestore, which is Google Cloud's equivalent for the DynamoDB. The structure looks basically the same as before, except we moved the API.go and cron.go from subdirectories to the root of the project. And the reason for that is that, as I mentioned before, you don't need to deploy binaries to GCP. You basically deploy the raw code, and GCP does the magic and just triggers the functions in your files. In packages.json, we again install serverless. An additional thing is that we install serverless Google Cloud Function, which is this plugin that I mentioned that kind of sucks. Serverless.yaml, again, it has some provider-specific things, and then we define, again, two functions. And you can see that before we had a handler was basically a binary file, and now it's just a function inside our code. And here you can see also the first workaround that we had to do. So basically in AWS, you just say that I want this function to run as a cron, and here you actually need to use two additional GCP services to set up this. So we basically need to use Google Cloud Scheduler that pings Google Cloud pub sub topic, and then you need to subscribe your Cloud Function to that PubSub topic. So it's kind of like a workaround, but it works. Again, example of the code. As I mentioned, the main function went out. So we basically just trigger the fetch measurements function. Here you can see that as an argument to a fetch measurements function, we have this PubSub message, which is basically something that is related to the provider. Basically, if you're subscribed to a PubSub messages, you need to include this. Again, the API example does the same thing as before. Basically, the whole logic of the code is the same. It is just missing the main function again. And as I said it before, you can also deploy this really easily. Basically, you need just Google Cloud Project, you need G-Cloud SDK, and you need the proper credentials. And after you set this to that .env file, and after you run make setup and make deploy, you will again end up with a link that, again, it returns you. I need some time to, it returns you the same data, but just this time, this thing is hosted on GCP. All right, and the third example is a GCP Cloud Run. And this is basically a service introduced by Google, like just recently. And the best thing is that you can write your code in any kind of programming language, because at the end you deploy Docker containers to GCP. So just do whatever magic you want, deploy to Cloud Run, Google will take care about everything else. The folder structure, again, looks quite familiar, but there is no more packages.json and serverless.yaml because we don't need this framework anymore. And we introduced the Docker files for two services. The cron code, again, looks the same as before, except now we have a main function that basically just exposes our application at port 8080. And this is basically the default port for the Cloud Run to handle. The same thing happens in API.go. We again just export this service to port 8080. So at the end, we have cron and API exposed to the public, which is not cool, but I believe that some interesting stuff will come up from Cloud Run, and that then you can do this trigger somehow differently. Basically, this is an example of a Docker file for the API service. And what we do here, we just build our API service on Golang image, and then we copy it to an Alpine from where it is it's served. And the Docker file for cron basically looks the same. We just build a different code. There's another file, cloud build.yaml, which basically just connects these two Docker files together. This is something that is, again, specific to the GCP, but it works good when you have multiple Docker files and you need to deploy multiple services to the Cloud Run. Again, a README file that guides you through this, how to deploy your application. The dependencies are the same as before, like GCP projects and stuff like that. And again, after a couple of minutes, you end up with a link that it's exposed to the world, and Cloud Run handles everything. So that's basically it with the examples. As mentioned, I suggest you, if you have time, go through the code, try a bit, do some changes, deploy again. It's cool. If you are wondering if we are doing serverless in Kiwi like this, well, not actually. We kind of have, like our workflow looks like that. So basically, if you as a developer, you start a new project, you take a serverless cookie cutter, you create a basic serverless project, you make a pull request to one Terraform project, which basically takes care about your credentials. And after a couple of minutes, you basically have a project deployable from GitLab CI, and you can like set up how many stages you want and stuff like that. So yeah, as I said, after 5 minutes, you can have already a working version of a future serverless project. And yeah, that's basically it from my side. If you have any questions now or later during the beer time, just...
And maybe it's a naive question, I've never used serverless things before, but I was wondering why there's a node dependency, or why is there a package.json and npm things?
Yeah, you don't need it basically, but we use it because we are using Serverless Framework, which is basically for AWS, it's quite cool tool that helps you to write more structured, more structured configuration, because otherwise you need to deal with the really weird AWS config.
Right. So your example could have been more complicated if you hadn't used that.
Sorry?
So would your examples have been more complicated?
Let's say like that.
Yeah. Okay.
It's just one additional layer.
Right. Thanks.
Have you tried one tool called, it's written APEX, which is I think written in Go, it's another serverless framework. And it actually you just need a binary, I think that configuration file, so you get rid of all the nodes.
Okay.
Maybe.
Okay, sounds interesting, but I haven't tried it.
Because the best thing of running Go is that you don't have to run node. So. And then have you performed any benchmarks comparing how long did the lambdas run and the same in GCP?
We haven't done that, but I saw an article a couple of months ago in some newsletter. I don't remember the results, but I think Lambda was much faster. I mean, Cloud Function is still like in some kind of development progress, and they're slowly adding stuff. So this is the reason why we won't migrate stuff from AWS Lambda to GCP Cloud Functions, at least not yet.
Because in Lambda there is this program which is like warming up the lambdas, no? That you need to execute every sometime.
Yeah, I think there is something like that.
You get this cold starts, but I don't know if it's just in Node or also in Go or this, you know.
I think it's for everything. I'm not sure. They probably just, as the Ruby servers, if you don't make a request for, sometimes they just go to sleep. Then you wait for the first request for half a day. But yeah, I don't know the exact results. I can find the article if you are interested. Anything else?
Questions? I have one question. What is the main difference between writing a code for serverless and for servers? I mean, do you need to keep in mind some things when you write a code for either Lambda or something like that? I mean, to control the source in different way. I don't know. Maybe to not use something else.
So the main difference between serverless and
when you write a code. When you write code for Lambda and you write a code for server, for example, you write just
okay.
What's the difference?
Yep. It basically, for GCP Cloud Functions and for AWS Lambda, you need to write the code in some specific order, let's say, and you need to, your handlers should also accept some provider-specific arguments and stuff like that. So, but the end, the main logic is the same, but the handlers which are getting the requests, sometimes they look a bit different than usually. So, but this is all in documentation. When you start it, it's basically just copy-paste.
And I also think you cannot write stateful applications in Lambda also,
Sure.
because you cannot share anything.
Yeah.
So you just can write stateless code.
True. That's why I said, like for some Slack bot and stuff like that, it's cool, but it's not a thing that you use to make huge applications.
I was wondering if you had any kind of numbers to, like a success story of, we ran it on a server, it cost this much, we ran it serverless and we saved this much.
I see.
If that's true, if you think that's true, I guess that's why you do it, right?
Yeah. We don't have those numbers. Yeah, we kind of.
But do you think it's cheaper? Maybe.
It depends, but definitely, if you need something, that you will ping 10 times per day, then, and if you are already using AWS, then this is probably the best way to go. Or, I don't know, you can also set it up on your server, but then, if you need a new server for something like that, then it doesn't make sense. So, I don't have the exact numbers.
Sorry.
That's a good question. As I understand, you run serverless simultaneously on AWS and GCP, right? And there is the same code, or there is a different functions, different.
You mean this example, or? You mean for this specific example?
Like in production, for example, you run a different.
Oh no, we don't do the same thing.
So you run mostly on
it's just one. If we built, I don't know, let's say 10 serverless applications in last year, and we deployed it to AWS, we're not moving this to GCP because it's just unlikely.
Yeah, I was wondering what is the reason to run different cloud providers.
No, but some new stuff are going to GCP directly, so.
Okay, all stuff in AWS and new stuff in GCP, right?
Let's say that's that's where we want to come.
Why did you choose GCP for serverless, or you just decided
No,
to
it's the whole thing.
Okay.
The whole stack is moving.
And one more question, what is better? You think what is better currently, Amazon or Google for serverless purpose? Okay, what is faster? Faster.
Yeah. I mean, Google is doing really cool stuff now, but they are few years later, so let's see in the next couple of years.